Good. So chapter 5, relationships within triangles. As anything, this is our first section of our chapter, and it's a building block of what we're going to learn in all of chapter 5. So today's a pretty easy lesson talking about midsegments. The first definition, the definition of midsegments, it says it's a segment that joins the two midpoints of two sides of a triangle. So if I know that DE is the midsegment, I know that D is a midpoint, which means that this segment and this segment are the same length. I also know that E is a midpoint, which means that this segment and this segment have the same length. Be careful not to assume that these two lengths are the same and that these two lengths are the same. They might be, but more than likely they are not. Keep in mind that when I draw these pictures, usually they're nice, neat, and pretty. This will be for any triangle. So even if you have a triangle that looks like this, you can still create a midsegment. If this is my midpoint here of that line, that means that these two segments have the same length. And this is the midpoint of that line, meaning these two segments have the same length. This would be called my midsegment. You can do that all the way around, any two sides. Midpoint of this side, midpoint of this side, connect them, that's a midsegment. So just because it looks nice, neat, and pretty doesn't mean it doesn't apply to any kind of triangle. So know the basics, which is it joins the two midpoints of two sides of a triangle. So that's your definition. Taking it a step further, the theorem says that if you know that it is a midsegment, you know two additional things. If DE is a midsegment, it is parallel to that third side, and it's half the length of that third side. So again, if I know that D is a midpoint and E is a midpoint, I can call this a midsegment. It's parallel to this side, and it's half the length of that side. So remember that this means therefore, remember back from chapter 2? So therefore we know that that's parallel. I wrote down two different ways because we need to know it both ways. Half of AC is DE, or 2 DEs gives you an AC. So double this gives you this, half of this gives you this. Goes either way. Yes?
So that means that for when you made the extra midsegment you made on the one before, that line that you made, the one going like this way, that's parallel to that side.
That's exactly what I'm saying. So this would be parallel to this. It's just a sketch, but keep in mind that, yeah, this is parallel and it's half the length of that one. Yep. Okay, let's look at some examples. So it tells us in the directions DE is the midsegment. Before you start assuming, be careful that you look to see that it's either given to you or it's marked like it is in my diagrams. I can call that a midsegment because I can see that E is a midpoint and D is a midpoint. Here it's just given to us. So looking at example 1, we need to find X. These should be pretty easy. What's X and Y? Ryan?
14.
Why?
Because having for DE is half of BA.
Good. This is a midsegment because they told us. Because this is a midsegment, it's half the length of this side. So if it's half, then going in the other direction, X has to be 14. What about example 2? What's X?
8.
Lily, was that you?
Yeah.
It's 8. I agree. Can you tell why?
Because it's like for this segment, so yeah, but the one side is congruent to the other.
If I know that this is a midsegment, it tells me it is. Here's my midsegment, which tells me that D is a midpoint. If D is a midpoint, these two segments are the same. So if this is 8, this is 8. How about example 3? What's X? Peyton?
17.
Good. Why?
Because it's half of what's on the bottom, so 34 divided by 2 is 17.
There you go. This is half of this, so 34 divided by 2 gives me X of 17. Okay, so these are 3 scenarios of things that I want you to understand with our midsegment. Those are pretty easy ones. Looking at my last example, it tells us that in triangle GHJ, the bigger triangle, that D, E, and F are midpoints. Here's a midpoint, midpoint, and midpoint. So just by knowing that, I know that DE is a midsegment. I know EF is a midsegment. I also know that DF is a midsegment. That's going to help you on your next step. It says that EF is 2x plus 7. And GH, which is this whole length, is 5x plus 1. They're asking us to find what EF is. So the way you want to set this up is to think about the relationship between the two. So we obviously have these two segments as being defined. What's the relationship between EF and GH? Ella?
Wouldn't EF be double GH?
Good. Do you hear how she said that though? Just very informally. So we can reinterpret that into an equation and say 2 EFs gives me a GH. You could write that 2 different ways. 2 of this gives me this, or you could say half of this gives me this. Either way is fine. So now I would strongly suggest you do it the way I'm doing it. That way you don't make a mistake. So now let's plug in what we know. 2 EFs is equal to a GH. So things that I've always told you guys are still going to be helpful. Mark up your diagram. If they don't give you a diagram, draw one. And always start with the basic before you start plugging things in. So how do I solve this, Rachel?
You wrote a plus for the 5x plus 1 up there. It says
Oh, thank you. I did that in 2 different places, didn't I? Thank you for catching that before I got too far. Okay, what's my first step in solving this?
Distribute the 2 over to the 2x and 7.
Let's distribute first. Now what? Go ahead, Tyler.
Subtract 4x on both sides.
Now you want to move your variables to one side, your plain numbers to the other, and of course get x by itself. So when I subtract 4x and move it over, because I'm subtracting 4x from both sides, and then of course to get that x by itself, we have to add 1 to both sides. And we get x is 15. Remember to always make sure you answer the question. It says to find EF. We only found x. So what's my next step? Plug it in. So EF is 2 times x plus 7. So what does that give me?
37.
So EF is 37. That makes sense? Okay, take a minute and write down your homework over there. Okay, we're good.